Hello everyone, welcome back to video lecture on OpenCV. This is the sixth video lecture you are watching. In the previous video lecture, we learned how to access pixel information from the mat. In this video lecture, let's play with what we have learned till now. In this tutorial, I'm going to consider a frame from a video file and one more frame from a camera. I'm going to club the both frame to form a single frame, and I'm going to display it on a window. The frame size of frame from video file will be 480 pixels cross 640 pixels, and from the camera 480 pixels and 640 pixels. So club to form, it will give you nearly 960 pixels in height and 640 pixels in width. I have already written a program and I'll start explaining to you. There are two video capture is required. One is for camera and one is for a file. In the file I have mentioned the path. Be aware that do not use a backward slash, because if there is a T after the backward slash, it treated to be a tab, not an file path. I'll check for whether the camera is opened or not. If the camera is not open, you have to return back, or else you can go forward. And also you have to check whether the file is opened or not. Or if the file is not opened, you can give a error message. If the file is opened, you can proceed. I need two frames. One is from frame for a camera, which is cam frame, and one is frame for a file, which is file1.frame. Next is I need to set the ratios, frame width and frame height for the camera. So I'm setting it using a dot set method for the video capturer camera. Width will be 640 and height will be 480 pixels, and I'm creating a window where I'm going to display the mixed frames. And here is a while loop which runs continuously until unless you press escape, or when the frames in a file is get over, this while loop exits. In line number 27, I'm accessing a frame from a camera and I'm checking whether the camera frame has a data in it or not. If it is not, you have to get back and the while loop runs again. If the frame has data, it continues. And here you are checking whether the file has a frame or not by using grab method. If it has the frame, you can forward. If it doesn't, then it means file is over. All the frames in file is already being accessed. Once you are confirmed that there is a frame in a file, then you can read it from using a read method, and whatever the frame that you have read from the file 1 will be stored in file 1 frame. Next, you need to resize your frame. As we don't know what is the frame size at this point of time, so we need to resize it. For that, I'll be creating a variable t whose size is of 480, 640. 480 is rows and 640 is width, and its type will be CV underscore 8UC3. 8U stands for unsigned integer of 8-bit. C is for channel, 3 channel, so it's a RGB image. This T can hold RGB image, and each pixel data will be of 8-bit wide. You have other format too. You can go for 16U or 32F or 64D. 32F stands for a floating point and 64D stands for a double type. Once I declared a variable t, I need to resize this particular frame to t. How to resize it? So we have an inbuilt function known as resize. In this function we are sending few arguments. One is the input frame, that is file frame, and one is output frame, this particular frame, and its size. So we are sending 480, 640 in the third argument, and fourth and fifth arguments are 0, 0, and one more argument CV inter area. So let's see what this resize function does actually from the documentation. The resize function is available in image processing, geometrical image transformations. Here it is resize. So if you see, it doesn't returns anything. It takes the input array, output array, size, double fx. By default it takes 0, by default it takes 0, by default it takes a interlinear interpolation type. So let's see what does DST and size does, and what this FX and FY are. So DST is for a destination or output image. If it has a size D size, if you send a D size, the DST size will be equal to D size. If you are not sent it, the size of this output will be calculated using FX, FY, and the size of the source. Imagine if the size of the source is 100 cross 100 and you are sending here 0, the FX is 0.5 and FY is 0.5. This 0.5 is multiplied to the row of this particular image, that is 100. 100 into 0.5 becomes 50, and this 0.5 into column of this 100 cross 0.5 again becomes 50. So the destination image size will be 50 cross 50. And the last argument is interpolation type. There are many interpolation type. One is nearest interpolation method, interlinear, interarea, intercubic, and interlancozos 4. In the last, they have mentioned that to shrink an image, it is better to use inter-area interpolation. To reduce the size of the image, you use this particular interpolation method, and to enlarge the image size, either you can use intercubic or interlinear. Intercubic is somewhat slower, whereas interlinear is somewhat faster, but the best possible enlargement you will get from intercubic. So in our image we need to shrink the image, so I am using CV inter area, and the size will be the same size of the T. So I am sending T dot size. Size is a function available in mat. I need to declare a variable final frame, which is the final frame of combined frames, which is of type again 8UC3, which is for 8-bit channel 3, and the size will be 960, 640. This final frame dot set to 0, it initializes the final frame to 0 everywhere. Then we need to split the two frames from camera and file. So I'm making use of vector mat. One is cam planes and one is file one planes, and one more is final planes. Final planes is nothing but planes for this final frame. File one planes is nothing but planes of file one frame, and cam planes is nothing but planes for camera frame. So here we have three split functions. One is for splitting a camera frames into camera planes, one is for splitting T into file planes, file on planes, and one more is splitting final frames into final planes. Next we require a few for loops. One is for the first for loop is for a channel, and the second for loop is for row, and the third for loop here is for a column. So in the row for loop, we know that its row will be maximum of 960. We require 3 pointer variables for row. One is for accessing the row of camera frame, one is for accessing row of file on frame, and one more is accessing rows of final frame. So I initialize final frame with x final, and here if the j is less than 480, that is if rows are less than 480, I need to copy the frames from file 1. So I'm instantiating the x file 1 in this particular if loop. If row is greater than 480, then I need to instantiate it from a camera frame. And don't forget to mention this j minus 480. Imagine if j is 480, 480 minus 480 becomes 0, so it gives you the 0th row of cam plane. If the j is 481, 481 minus 480 becomes 1, so it gives the first row of cam plane. Once we are initialized with rows of cameras and file frame, let's go for a column where we copy the frames, the data from one frame to other frame. So here k runs from 0 to 640, is the width of the last final frame. When row is less than 480, I am copying the file on content into the final content. Or if the row is greater than 480, I am copying the camera frame to a final content. And we require a merge, as we seen in the previous video. Merges the final planes into one RGB image, which is T, and I am displaying the T in my mix frame window, and it's for waiting 20 milliseconds. If there is a key press, if it is the escape key, then I'll break the loop, or else if it is any other key, I won't break the loop. So let us see, let's compile it now. Control Alt F7 for rebuilding. So it is success. Let us run it. See, in the top position of a video frame is running, and in the bottom frame a camera frame is running. So this is what the output that you will get once you run this particular application. So let me press escape. Again press escape to get rid of the running of application. This was done under debug mode. So if you want to go for a release mode, just change it to release. So when the mode becomes release mode, it takes the DLL files from this particular path, the path which we have mentioned in the release property sheet. If it is debug, it takes from a debug property sheet, the paths for a DLL from debug property sheet. So this is it in this video lecturer. The C++ file will be available for download, so you don't have to write it from the scratch again. Thanks for watching this video lecture. Don't forget to subscribe my channel, and don't forget to like the video.